So if 5 grams of copper metal, alright, so in here 5 grams of copper metal is given and it's react with 20 grams, solution containing 20 grams of AgNO3. So in here 5 grams are given and 20 grams of AgNO3. Now out of these two, which one is a limiting? That we need to find, and then we need to find out how much we can produce, how much Ag we can produce. So once we determine limiting reactant, and then we can find how much Ag we can produce. Okay, so let's start with, I'm going to go to next slide. This is the balance equation. 2AgNO3 plus copper 2Ag plus CuNO3 2. Now we start with 5 grams of copper first. 5 grams of copper. We have grams of copper, we convert into moles of copper. So 1 mole of copper, which is 63.5 grams. This is the molar mass of copper, and when we cancel grams, you convert into moles of copper. When you look at the balance equation, this is 1 and 2. 1 mole of copper used up produce 2 moles of Ag. So when you multiply 2 mole of silver produce when it's used up 1 mole of copper. So when you do that, 1 mole of copper, 1 mole of copper cancels, you convert to moles of Ag, silver. Alright. Now you have moles of silver to grams of silver, multiplying by its molar mass. So 1 mole of Ag, and you get 107.9 grams of Ag. When you do that, you cancel moles of silver and convert grams of silver. You get about 17.0 grams of silver. Alright. Now we have given 20 grams of AgNO3. So we do the same thing. 20 grams of AgNO3 we convert into moles of AgNO3. So 1 mole AgNO3, and we know that molar mass of AgNO3 is 169.9 grams. Okay, so when you do that, you cancel grams of AgNO3 and grams of AgNO3, you convert moles of AgNO3. Now when you look at the balance equation, there is a 2 to 2 mole ratio because 2 moles of AgNO3 used up and 2 moles of Ag produced. So that's simple. 2 moles of Ag and 2 moles of AgNO3. Okay, so when you do that, moles of AgNO3 cancels, you produce moles of Ag. Now, molar mass of Ag, which is 107.9 gram, and 1 mole Ag. When you cancel out moles of Ag and then manipulate this number, you get about 12.7 grams of silver. Now when you look at these two numbers, 5 grams of copper produce 17 grams of silver, and 20 grams of AgNO3 produce 12.7 grams. Let me write down grams. It looks like 79. No, it's 12.7 grams. Out of this one, we can consider the least amount, 12.7 grams. So that's where we can say AgNO3 is limiting reactant, and that's why we can produce 12.7 grams of Ag silver we can produce. So based on that you can calculate, alright, which one is limiting and which one is excess and how much you can produce. Okay, I'm going to give you guys one more example on percent yield. So if you have C3H8 which combusts in presence of oxygen, it gives 3 moles of CO2 and 4 moles of H2O. And if you start with 5 grams of C3H8, what is the theoretical yield? And then okay, so let's start working on A, and then I will write B also later on. But since we have 5 grams given, so we can convert 5 grams of C3H8, we convert into mole. 1 mole equals 44.0 grams. Okay, now looking at the balance equation, it is, and here theoretical yield of water, let me add that one here. When you look at this, it's a 1 to 4 mole ratio, right? So we can have 4 moles of H2O and 1 mole of C3H8. You do that, moles of C3H8, grams of C3H8, alright, that's cancelled. And now we have moles of H2O, we convert into grams of H2O. We know 18.0 grams of H2O, 1 mole of H2O. In that case, moles cancel, you convert grams of H2O, and you can produce about 8.19 grams of H2O. That's the theoretical yield. Now, let's say if B, I got a percent yield of 75%. How many grams of water did I make? Okay, so let's say if we have given 75% yield, we know that X divided by our theoretical yield, 88.19 grams times 100. This one we need to find our practical yield, experimental yield. Alright, so when you solve that, you get 6.14 grams of water that you can make. This you got theoretical. This is the one you got theoretical. You need to find X, that is experimental yield. Alright, so actual yield, that's what you need to find. And when you plug that in this formula and solve for this X, you get 6.14 grams. Okay, I'm going to go for one more problem. Be plus 2HCl, and you get BeCl2 and H2. And my theoretical yield of BeCl2 was 10.7 grams, and if my actual yield was 4.5 grams, what was my percent yield? Now you know this formula, percent yield equals actual yield divided by theoretical yield times 100. So when you plug that numbers, actual yield is, it is given 4.5 grams, theoretical yield is 10.7 grams, and times 100, you get percent yield is 42.06. That's your percent yield. So you can calculate that. In here it's very straightforward, percent yield and actual yield is given. In some you need